Good morning, Professor Chaudhary. A very warm welcome to you, and thank you so much for joining us today. I'd like to start by asking you to give us a brief introduction, a little bit of your bio, your background, where you are now, and what brought you from Buffalo to CASE, and sort of your journey through the startup community as well and academia. So if you could give us a brief bio, and then we'll get to the questions.
Oh, thank you, Dr. Kannan, for the invitation. Glad to be here. So I'm currently the Kevin J. Kranzusch Professor and Chair of the Department of Computer and Data Sciences at Case Western Reserve in Cleveland. Prior to this, I was a professor at SUNY Buffalo. And from 2016 to 2020, I was an IPA at National Science Foundation in the Office of Advanced Cyber Infrastructure. And I've been in academia for, well, it's over 30 years now. And in between, I've taken breaks to get involved with startups of all sizes. I've done some of my own startups, and primarily they have been related to high performance computing, to cloud computing, to using computing in medicine, and in general, the space of high performance computing. And Case Western is a small private university, but it's one of the top 20 private universities in the US in all aspects, including the federal research expenditures, and it's top 15 in the research translation into commercial success. We were founded in 1826. It has approximately 5,400 undergraduate students and 6,500 graduate students currently. And our faculty strength is 3,700 full-time faculty. So that's an excellent faculty to student ratio.
Great. So thank you so much for the introduction. So let me start with the formal questions. The first few questions talk about, graduate level programs. So could you tell us a little bit about the AI or AI-related graduate and doctoral programs that are offered at your institution? What makes them unique, and how large is the program?
Okay, so Case Western is very well known for its medical and engineering programs. Mm-hmm. We are a relatively small department, that is the Computer and Data Sciences, within the Case School of Engineering. We have currently 16 full-time faculty, but we are growing rapidly, and we are doing multiple hires currently and in the subsequent years. Mm-hmm. So it's a fairly unique department in that we have combined computer science and data science pedagogically into one department. Mm-hmm. So there is just a tremendous overlap in background and course requirements for these two degrees, and that meshes very well with AI. So focusing on the graduate programs, clearly AI is the most sought after area of concentration, thesis or PhD dissertation. Mm-hmm. Students are typically required to take at least 3 courses in a concentration. Mm-hmm. That is overwhelmingly tilted towards AI, and most of them tend to take more than that. Within the department, we have over 60 PhD students currently and over 100 master's students. And as you would expect, these numbers are growing very fast. Mm-hmm. Additionally, Case is a very collaborative school in terms of research and teaching. It's a smaller school, so very conducive to that. And so many in our department, they work on problems in healthcare, in medicine, materials, manufacturing, and so on. So we collaborate with other departments at Case and Cleveland Clinic, which mm-hmm. is really big. So the need for AI from these other disciplines wanting to explore is incessant. Mm-hmm. And being next door to Case Medical School, university hospitals, Metro Health, and Cleveland Clinic gives us that competitive advantage, and we collaborate very closely with them. We are constantly pushed by these other departments and institutions to work collaboratively with them to have our PhD students, master students work in projects related to what they are doing.
Okay. So you would say that's sort of a unique feature of the program at CASE, the strong connections to the health, and you talked about material science.
Material science and medicine and healthcare in general.
Okay. So let me piggyback on that question. So what do you see as the key research areas? You've talked about applications, but where do you see foundational research in AI? From your perspective, where do you see that moving? Are these applications driving new research in foundational areas of AI?
Yeah, so there are a couple of problems that I can talk about, and clearly this is biased because these are some of the projects that I'm involved with. One of the areas is what I call performant AI. It goes much beyond just that computational performance, which clearly is highly desirable. And a lot of the major progress in this area of AI or a sub-area, say deep learning, is due to high performance computing. The learning algorithms take too much time, and sometimes you have to learn at the edge. So speeding up these algorithms is critical. But to me, performant also includes other performance measures like accuracy, transparency, trustworthy, privacy, fairness, etc. So I can talk about one of our recently granted NSF AI Research Institute. It's got an acronym called ICICL, which stands for Intelligent Cyber Infrastructure with Computational Learning in the Environment. It's a mouthful there. That was funded this year, and we start next week, November 1st. It is led by Professor D.K. Panda from Ohio State, who's the PI. I am the co-PI from CASE, and we also have Indiana University as co-PI in this. And there are 10 other participating institutions. It's got 46 investigators, so it's really broad and very collaborative. So it's a national infrastructure which is going to enable AI at the flick of the switch. And this is utility computing. The concept has existed for a long time. And I think we are at a point where we can probably make this happen. So we expect ICICL to transform today's AI landscape from, a narrow set of privileged disciplines to one where democratized AI is going to empower all kinds of domains through what we call the integrated plug-and-play AI. Okay. So we are going to foster, catalyze foundational AI and CI, and by CI I mean cyber infrastructure, and we will transform the application domains. So the goal is to enable transparent and trustworthy national infrastructure for AI-enabled future, which will address many societal problems. And I'll talk a little bit about some of the problems which are driving this initial effort. And clearly, with these institutes, we'll grow new generations of workforce and clearly try and incubate companies and with sustained diversity and inclusion at all levels. So the main technical thrust for cyber infrastructure for plug and play AI, or as we call intelligent cyber infrastructure. And it also looks at the field's edge to HPC cloud. So today, most of the AI is being done in the cloud or in HPC centers, but more and more edge devices are growing. So how do you enable that plug and play for many of these applications? So we will democratize AI by these characteristics. And so this requires that we build a new cyber infrastructure. And the intelligent cyber infrastructure that we call, it has two components. One is, what is the cyber infrastructure needed for appropriate AI? So we call that AI for CI. And then you also want to use AI for that CI for AI, right? So it is sort of a virtuous cycle, right? And we also advance foundational AI, and that supports model commons, conversational AI, privacy preserving AI, adaptive AI. And then we have three domains of use-inspired research. And here we co-design for that targeted domain. So initially, the use cases are from smart food sheds, animal ecology, and digital agriculture, which are typically not well supported by AI and CI. And so here, as you can imagine, in these kind of systems, we need to provide a continuum of this field to edge to cloud HPC centers, right? And you have extremely large, complex, heterogeneous data. And so we are going to augment the current cloud-based AI models by facilitating this design decision-making in the field, which today is plagued by many problems, one of which is the low network bandwidth, right? And how do you allow data to be private, but facilitate collaborative intelligence? How do you provision models to use and then plan computation and data movement, which typically is the Achilles heel for performance? So the key value proposition that we have is to democratize AI. And here we will develop rubrics for training the next generation of researchers who can translate from use cases to AI-powered cyber infrastructure. And so integrating all these emerging AI technologies with advanced cyber infrastructure capability, we will be able to develop this roadmap for future AI-driven science and cyber infrastructure. And so it's truly building a nexus of collaboration between AI experts, cyber infrastructure experts, and domain sciences.
So that's the trinity, Vipin. I think that's something that NSF and agencies have been talking about for a while. So can I push you a little bit, because I know your background. You come from the CI community. There's a lot of talk about investments in HPCs, large, supercomputing facilities, etc. Do you see that as how do you see the balance between that and moving to the cloud? Because when you're talking about democratization of AI and cyber infrastructure, it's access to that's a problem. And then in India, as you're aware, the issue of localization is also a problem. So how do you see these two sort of competing forces in terms of investments in large infrastructure versus cloud, which typically is controlled by a few large companies? So can I get you to give me your opinions about that?
So I think it's going to be a mix of both of those for the foreseeable future. There are pros and cons to both. If you have a large enough group, if you have a lot of compute data requirements, and you have those requirements to use the facility 24/7 by 365, with a large enough group, you have the expertise to manage and do that. It'll probably be cheaper there. And then you also help enable people learn while supporting such an infrastructure. However, a vast majority of folks would not want to be engaged in dealing with system maintenance and taking care of large infrastructure. And a lot of them probably don't even need such a large infrastructure. So for them, cloud is a terrific modality to use. And so I think both of them are going to continue. There are clearly some issues with cloud, because getting access to data and transferring data and then moving from one cloud to the other, there are still business challenges, there are technical challenges. But I think increasingly you are seeing even the federal funding agencies in the US, allowing for PIs to use cloud and enable that, which, even just a few years ago was not possible. So I think both of those are going to continue. You want the academic community, the research community to do research in the cyber infrastructure space itself. And if we don't do that, then we are not going to be able to push the frontier on that. Then you're always going to just buy what the industry currently has. Okay. And I think that's a disservice as well. So,
great. Thank you for that, because you do have that unique perspective. So I appreciate your response. So I think let me circle back to questions about, you have this new AI Institute, and you talked about where you see new areas of research emerging in both foundations and applications, and you've talked about this virtuous cycle. With your program and the demand for students with AI degrees or machine learning degrees, how do you encourage students to stay on and pursue a research career? Is that I'm sure these are students, as soon as they finish, industry is just waiting to grab them. So how do you encourage an ecosystem that rewards students for the work they put in, but also creates the next generation of faculty such as yourself who can train the next generation of workforce? So how do we ensure that happens?
Yes, so clearly the student demand is strong for AI, and other domains, they want to work with computer and data scientists.
Yeah.
But as you correctly pointed out, we compete directly with industry. Many of the computer science and data science undergraduates, they go to industry instead of graduate school.
Right.
And this is due to the incredible salaries they get. Yeah. So we miss out many of the brightest students. And so clearly at this point, it is hard to recruit as many good graduate students with the appropriate background that we would like. It's also hard to recruit faculty in AI, again, due to the competition from industry and from other universities, because everyone is looking to hire in the same area. So the demand is huge, but it is hard to recruit, especially local graduate students and faculty, to meet that demand. And a lot of our students, graduate students, come from other countries. And clearly the recent COVID pandemic and the geopolitical situation has affected that as well. So there are different drivers for students. For some, it is money, and that's a hard one to compete with, unless you show them data that, you can now do research in industry. And today, there are a lot more research jobs in industry than a few years ago, and specifically in AI. And so you can do research, and simultaneously, you can make a lot of money as well. Right? And for that, you need to do a PhD. So, however, the real encouragement really comes from letting the students realize the impact that they can have on solving problems which directly impact the society that they know of. And so for us, being able to improve the aspects of healthcare and medicine, we found it to be very motivating to students. So many of our students, they work on developing AI solutions for problems in the medical domain. So the challenge is to introduce the students to research early in the program and provide them the opportunity to work with domain scientists with real problems. And most of our upper level undergraduate and graduate courses, they have project as a major component, and that greatly helps in attracting students towards research. And I cannot understate the importance of good mentoring and challenging the students with hard but with these impactful problems. We also see many students go to industry and then come back for graduate school because they were not able to find that impact which we can provide. And so I think being in Cleveland, things like all kinds of predictions in medicine, right? Dealing with noisy temporal data, which is multimodal and sometimes sparse. They impact all the foundational AI issues of trustworthiness, transparency, privacy, ethics, correctness. So with our collaborators, I think that is becoming a major emerging application for AI, actually not just for us, but around the world. There are other emerging applications in manufacturing. So these include the Internet of Things. So this will allow organizations to do better decision making. And cybersecurity is also an emerging application of AI, where we can, where AI is going to be used quite heavily.
So you've already talked a little bit about, the partnerships CASE has with, local industry and business and, with the other schools, especially the medical school. And you touched briefly upon agriculture, which is, a new application of AI. Where do you see the demand, if you look 10 years in the future, where do you see industry sort of pushing and saying, here's where we need more trained graduate students or PhD students? Where do you see that next demand? Is it manufacturing? Is it agriculture?
Interestingly, it's all of them.
All of them. Okay.
It's so hard to try and classify. I've been surprised by how even small companies locally here want to delve into AI and see, because the buzz is huge. Yeah. And so a lot of times people just go by the buzz. And so they want to explore. But clearly, if you have the right data, you can help in all of these domains. So just from a local perspective here, we have finance and insurance companies who are big users of AI, will continue to be big users of AI. They collaborate with us for projects and providing projects to students, trying to recruit them, internships for them, and so on. Retail and manufacturing. And of course, I've talked over the healthcare as well. So locally, these are some of the areas that we see huge growth, and this is across all of geographies.
Okay. So talking about this demand, do you think academic institutions are actually ready? Because in India, one of the questions that every newspaper talks about is we need 100,000, we need 500,000 trained professionals in AI, and I think the definition is broad. It looks at all aspects of the AI workforce, across the data pipeline. So, do you think academic institutions in the US are ready? Do we have the resources, the faculty, the type of training that's needed to really get industry-ready students?
So yes and no. I think we are making progress towards that. Clearly, AI is very fast evolving, and it's an expansive field. Engaging with industry is the key because they are the ultimate customers for your product. But I think the training has to be more foundational and not just using certain deep learning toolkits. So a lot of times people use the buzzwords of machine learning and AI to attract potential employees. And it really doesn't require AI as we are looking at. Now, users of many of these toolkits, they make life-saving or major economic decisions based on predictions from such tools. So it is important that people know the limitations of the particular techniques which are used in these tools. And these can stem from the inherent limitations of the techniques, the hardware used, limitations of the data, and so on. And I think we need to have growth in that aspect. Just a user of AI, I think, is one component, but I think the AI tools so far are not as mature as some other fields where you can just take an existing tool, plug and play, and use it for every application. And that's what people are trying to do. So I think we are making progress in academia to try and train folks, but clearly the demand is very high. It's hard to recruit faculty. And we also want to do more foundational. And so there is a lag, but clearly the signs that I see in terms of investments from all universities is to grow this.
So given you've been at different institutions and you've been at the NSF and you've looked at AI programs that crop up all over the US, are there any specific recommendations, or where do you see gaps in how the workforce is currently being trained, especially at the graduate and PhD level? Do you have any sort of advice for institutions either starting off or with existing programs? What do you see as ways they can enhance the quantity of students they produce or the quality of the programs? You've talked a lot about interdisciplinarity. I'm wondering if that's an issue you see as a major challenge.
So so going back to what I was saying earlier, it's very hard to take our existing local undergraduate computer science students and have a majority of them go into graduate school. That is a problem. The undergraduates, of course, also do a lot of AI courses in their undergraduate, and then they go to the industry and not for graduate studies. What we clearly see is substantial interest from non-computer science but STEM students who want to pursue graduate studies in computer science and with AI and that focus. So creating a bridge or a pathway for such students, that is certainly going to increase the number of graduate students in AI. And we've seen anecdotally here, PhDs in other sciences come and do masters in our program and change careers. So the challenge really is, how do you make this bridge fairly small and easy and not require them to do a full undergraduate? And the issue also has been about the quality of graduate students, right? It's getting harder, but that is required. And so I think looking at the current scenario, attracting top students from other STEM areas and providing the right bridge courses so that they have the appropriate CS background so that they can be successful in the graduate program is the key.
Okay.
And we've explored mechanisms to attract some of the top undergraduate students by involving them early on in research projects. And the students, the top students who do that, they have a higher chance of going into graduate school. And so we've started a joint BSMS program. And anecdotally, I've seen that some of the top students actually go for this option. And we've also seen some of these students hang on and do PhD. Of course, the funnel keeps reducing, but it's still happening. Clearly, in many of the areas that AI is being used, I think embedding students in a research group where you have experts in multiple disciplines, the domain, the computer science, AI, that is absolutely important. I think the computer scientists, of course, like to abstract problems and solve them. But I think it needs to be grounded in a domain so that we make the right assumptions. And the students also love to see the impact that they will have. And so working with domain, I think, is critical. And I think some of the programs that have been successful, including our new AI Institute, is where we are doing that. The concept of that convergence, I think, is really truly coming into play here.
Great. Thanks, Vipin. So the next two questions are sort of taking it one level up and looking at what do you see as the role of the government or different agencies in terms of new initiatives and investments in infrastructure, both physical infrastructure, manpower, to help create that AI workforce? And what do you see as the role of partnerships between industry and academia and government to sort of really accelerate progress? So given your experience with NSF and with the academic side and the industry side of things, what do you see as the sweet spot for everything coming together?
So I think it is critical, especially in AI, because AI is not just one discipline. It is being applied to so many disciplines. And the demand for AI from industry is huge. The NSF AI Research Institutes, last year, there were a couple of industries involved in the investment. I think that needs to increase because they are going to benefit from this. The government can only catalyze, right? And they have started doing that, but industry has to pull that. Especially true in computer science, where you are well aware that NSF funds most of the computer science research in US, and that's just about $1 billion. That's about 90% of all research funding. So that's very small. We need to increase that pool. I think the universities also need to start investing in AI. And I think the government can perhaps have programs to incentivize universities to invest more. Most universities still continue in their traditional decanal research allocation. And so that has to, I think, change as well. The workforce development, that is long-term. The pipeline has to start from middle school. There are some top STEM high schools in the US which offer more than one AI course in their high school. Right? I think this needs to happen more across other high schools, and you have to start going down to middle school. And I think here government can play a huge role with special programs. And research proposals which claim to use AI for certain domains, well, they should have experts as co-PIs from both the domains. I think you have to require that. So this is going to force that closer convergence of ideas and expertise. And that's where I think you'll make real progress in both AI and the domain. And this is something that the federal agencies can mandate, and they can enforce that. Otherwise, I think we are going to be working, as computer scientists, abstractly and solving, really foundational problems. But I think there's enough there that you can impact society as well while doing that. And similarly, the domain scientists, they tend to use the most popular tool out there without knowing how the inner algorithms work. And so that can lead to wrong conclusions. So in my personal experience, it's imperative to work closely with domain experts to find really the problems that need to be solved.
And you think agencies can sort of mandate that by saying, we need teams,
Yes,
collaborations, and
correct. And we've been doing that, but I think we need to enforce that a lot more. It should not be just lip service that I include a co-PI with their CV in there. I think there needs to be real skin in the game where they are putting the effort and doing that.
And how do you get more industry to the table in sort of a partnership mode?
I'm very encouraged by how, at least recently, NSF has been, and especially SAIS, has been working with industry. So there are many programs where industry is coming into play. Clearly, they have no shortage of cash to infuse. I think it is just the priority of the federal agencies to seek out engagements, and I think it'll happen. It's already happening, so that's very positive.
So then, to sort of take from the US and India individually, what do you see? So you're an IIT Kharagpur graduate, and I know you have strong ties with both IIT Kharagpur and other institutions in India. What do you see as opportunities for US-India collaborations, both in sort of research and this workforce development area? And are there mechanisms, models you think would be most effective in helping to both seed, catalyze, and then sort of scale things up? Because if you look at India, the demand is going to be huge. There's a clear shortage in India of even trained computer science. So where do you see synergies and opportunities for the two countries to come together, and sort of models that you think have already worked, and things, new ideas for scaling up the interactions?
So yeah, clearly both countries need to build workforce the capacity. And the AI institutes within US, they are encouraged to work and leverage each other. There are many different domains. So it would be good, and I know India also has several AI institutes, and at least Kharagpur has one, and I'm actually in conversations with them quite regularly. But I think it would be good if the institutes across countries, across the US and India, can also collaborate and do some workforce exchange programs. The issue always is researchers are always busy. They have enough on their plate. So how do you incentivize institutes and researchers to do such collaborations, to have much longer lasting partnerships? Because that's really, it doesn't happen in a year that you see the outcomes. So I think funding incentives would be great to seed such partnerships, and maybe a mechanism to do some matchmaking, because a lot of the colleagues across the two countries are not always aware of what's going on elsewhere, what programs exist, what institutes already exist. So if the groups, they engage, I think the partnerships will form. We somehow have to break that inertia. Most of the previous funding has just been, let's have a workshop with, researchers from both countries, and that's been the extent of the collaboration. I think it has to go beyond that. A good thing to start might be short-term visitor programs across the two countries. Long-term, I think, takes time. The groups have to gel, they have to have common problems. Student exchange programs, I think, can work. So how do you incentivize that? And then once this is done, I think then one can invest in longer term programs.
Because you're right. I mean, the exchange programs, there are examples. The question in India is always about scale. So you can put together a program that sends 20 students to US institutions, but how do you impact a larger number? So do you have any thoughts on how we could do something like that?
So I think you got to start small. right? If you even if you can get 20 students, another 20 students, that seed is very important, and it has to be, I think, both ways. It can't always be that 20 students come from India to the US and no one goes from US to India. I think true partnership happens both ways.
Okay.
There are many unique societal problems in India, and I think a lot of people get motivated, those who go into graduate school and so on, how they can impact to solve some of these problems. So that awareness, I think, can really enhance this bilateral kind of scenario. So I think one has to start, whether it be small.
Okay.
I think just going out without testing the waters in a very big way, maybe recipe for disaster. So you want to have at least some victories and scale.
Okay. All right, great. And you talked about a platform, right? A platform for matchmaking. Can I ask you to expand for a minute on what would be most effective?
So I think, so for example, your organization, if you have, and you know, all of this is public information, but to collate, you know, a directory of different PIs in US working on different types of problems, and the kind of funding mechanisms that they are using. And a lot of the well-funded programs have a big workforce development. They promote international collaboration. They promote collaboration across different domains. I think that knowledge and connecting them to counterparts in India. India is now investing quite a bit into some of these institutes. But unless I didn't have friends in some of these institutions, it would have been hard to just know about these things. So I think that there needs to be that aspect, and it needs to be publicized to relevant parties in both. So maybe there's something which is sent out from federal agencies showing what opportunities exist elsewhere and so on. But I think just creating a database of these things, that would be very useful.
Okay. So part of what we're doing under this USI-AI umbrella is also serving Indian institutions, seeing what sort of undergraduate, graduate programs they're offering in AI or data science, so just compiling that list. And in the US, there are such lists from NSF and other sources. So, I mean, at least putting that together so people understand that, beyond the IITs, here are the institutions, what types of degrees do they offer? So I think that might be a place to at least start the conversation.
Yeah, and we do see a lot of students from India for internships applying here. And I think that's a good way to jumpstart this. And it gets to be expensive, not just in terms of money, but in terms of the time requirements. So if there are centers, so having multiple students come to one lab for a summer, I think you can do a lot more that way. Rather than having these 20 students go to 20 different places, the effort is a lot more. So maybe some such cohort system can be created.
So something like the REU program where you have 10 or 15 students at a time. Got it. Great. Fantastic. Thank you so much. Vipin, any final thoughts?
No, I'm glad you're doing this. I think it's time. There are just so many problems that are now transcending boundaries, national boundaries. And clearly in US, the universities are always looking for the brightest and the best graduate students. And we are trying to get our local students to move into graduate school. But I think we have to think globally now. Okay. And so I think it's a win-win for both countries. So I'm glad that you're doing this and look forward to some positive outcomes of this.
Great. Thank you so much, Vipin. Appreciate the time. And what we'll do is we'll share the recording with you, and then if it's okay, we'll put it up on YouTube. So thank you again for your time and your insights. And we'll definitely follow up about next steps.
Thank you, Nandini. Pleasure talking to you.
All right. You take care. Bye-bye.
Bye.
Okay, I think I've stopped recording.